Last but not least is the parabola. The parabola is the only one of the conic sections that does not have both variables squared. It only has one of the variables squared. So you'll notice if we go back to a hyperbola, it has two squared variables, which means if I drew a line down the center vertically or horizontally, it's going to look the same on both sides of either a vertical line or a horizontal line. Same thing with a circle or an ellipse. But with a parabola, this parabola looks the same on both sides of a vertical line, but not a horizontal line. And same thing down here. If I draw a horizontal line here, the parabola looks the same on both sides, but not a vertical line. So it only has one-way symmetry because it only has one squared variable. Now, if I were to make a little t-chart for this, I would notice that, I'd get 0, 0, 1, 1, 2, 4, 3, 9, 4, 16, and so forth, because y is the square of x. So this makes an interesting pattern when you graph this, because this tells me if I start at the vertex and go sideways 1 unit, I'm also going to go up 1 unit. So 1, 1. But if I go sideways 2 units, then I'm going to go up 4 units. And if I go sideways 3 units, I'm going to go up 9 units. So for the basic parabola, that's what causes the curve, and that's why it continues to curve, because every time I go out one more in the x direction, the y direction gets bigger and bigger. It increases and gets more steep and more steep, so that causes it to continually curve upward. Now if I put a coefficient in front of the x squared term, so let's just kind of see what that looks like. I have 0, 1, 2, 3, 4. Then this is going to be 2 times 0, which is still 0. 2 times 1, which is 2. 2 times 4, which is 8. 2 times 9, which is 18. 2 times 16, which is 32. So when I go over 1, I'm going to go up 2. When I go over 2, I'm going to go up 8. This over 1 up 1 tells me what the coefficient. This over 1 up 2 tells me this coefficient is 2. Now, of course, the rest of the pattern has to hold for it to be a parabola. But if you're looking at a parabola and you go sideways 1 unit, however much you go up or down is going to tell you what that coefficient is. So here, if I have y equals 1/4 x squared, that means if I go over 1, I'm going to go up 1/4. And if I go over 2, I'm going to go up 1/4 times 4. 1/4 times 4, which is 1. So over 1 up 1/4, over 2 up 1, and I'm going to have a really wide, shallow-looking parabola. So if you want to make your parabola wider, you make the coefficient in front of the squared term smaller. If you want to make your parabola narrower, you want to make the coefficient in front of the squared term bigger. Now, if we have a sideways parabola, you can probably guess what's going to be changing. What changes is which variable is squared. So instead of we have y equals x squared, now we have x equals y squared. And I'm leaving a space for the coefficient because I don't know what that is yet. But following the pattern we did before, I'm going to think if I go sideways 1 unit, whatever I go up should be my coefficient. Notice I'm only going up a half right here. So let's make sure this works for the next. If I go sideways 2 units, then this should be 1/2 times 2 squared. So 1/2 times 4 is 2, and that's exactly what I get. Okay, so this is x equals 1/2 y squared. Now this one is exactly the same shape, only I've scooted it 2 units to the left and 1 down. So now my vertex, instead of being at 0, 0, the vertex is at -2, -1. So I'm going to do the same thing with the vertex of the parabola as I did with the center of the circle. I'm going to change my x and my y. So this is going to become x plus 2 is equal to 1/2 times, in parentheses, y plus 1 squared. We can double check that point. This looks like the point 0, 1, so I can check that in. If I make x 0, I get 2 equals 1/2 times 2 squared 1/2 times 2 squared is 1/2 times 4, which is 2, so that checks. Okay, so we can, so what if I didn't know what that coefficient was? Let's look at that in the next, in the next time, a different method of doing this. I'll show two methods for the next one. So now we have one that has a vertex of 1, -2, but it's pointing upward in the y direction. So this is going to be one that is y equals x squared. So I have something with y and something with x squared, and I have to figure out what numbers go where. So the -2 as the y vertex is going to make this +2. This is going to become x minus 1, and then I have to figure out what this coefficient is. So right now, let's just call it a for right now, and let's pick a point on the graph. So I see a point on the graph, and you want to pick something other than the vertex. I see the point 0, 1 here. So if I substitute 0 for x and 1 for y, I can solve and figure out what a has to be. So let's do that down here. I have 1 plus 2 is equal to a times 0 minus 1 squared. So 3 equals a times -1 squared is 1. So a equals 3. So that means my equation is y plus 2 is equal to 3 times x minus 1 squared. Now notice, and I probably ought to write that in a different place here. Let me kind of scoot it. So there's the equation now for this one. So that's the equation for this. Now notice another way I could have done this is when I go to the sideways 1 unit, how much do I go up? 3. So that also tells me that coefficient. Sometimes it's really easy to tell from the graph how far up you go, or up or down, or right or left for that matter, that when you go sideways 1 unit. Sometimes it's not easy to tell from the graph. So that in that case, you'd want to pick a point and solve it using the more algebraic method. Now I do have a little story that might help you remember which direction the parabola opens. Once upon a time, there were the X twins and the Y twins, and they were very happy and loved to camp and go hiking and so forth. And one time they went camping, and one of the X twins was missing. And the X looked, the X's and the Y, the remaining Y's and the remaining X and the 2 Y twins looked and looked and looked, trying to find the missing X, but they never did find it. And the poor little X twin was so devastated. He had little tears running down his little face. So crying, he was crying, and he was looking and looking. So where do you think the X twin would look? Well, he would look along in the X direction. He would look this way, or he would look this way. So if we have an X equals Y squared, we're going to see the graph pointing in the X direction. Now if the Y twin had been missing, if I had 2 X's and a Y missing, then I'd be looking in the Y direction for the missing Y value. So if I have x squared equals a y, or I should say y equals x squared here, if I have y equals x squared, the graph's going to go up or down depending on what the leading coefficient is. It could be positive or negative. If I have x equals y squared, the parabola is going to point right or left.